So let's begin, shall we? Today's topic is gonna be command injection, and more particularly how I managed to pass the skills assessment on Hack the Box, because it was, to be honest, quite interesting, and I also saw a lot of people struggling with it, and it does require a little bit of patience, like every single thing in penetration testing. So without talking too much about it, let's just begin and I'll just show off how I managed to compromise the web application. So I got the box running already, so I'm just gonna go to the URL and it shows me a login page, tiny file manager, whatever that is. And in the description of the assessment itself, it says that we should authenticate by entering the following credentials: guest and guest. So essentially, I log in with the credentials provided, and what I can see right in front of me is just a bunch of files, as it says right over here in the left upper corner. It's some sort of file manager, so it's supposed to be managing files. So what I currently know is that there are somewhere in the application supposed to be a command injection, and I gotta find that and do my best to exploit it. And to be honest, I found it a bit more time consuming to find the injection itself. I mean, in general, this is the bigger part of penetration tests, if I could put it that way, just finding the vulnerability itself. But once you get into that, it's fairly simple to exploit it. So I have a bunch of files here, nothing too interesting. You click on a file, it just redirects you to this endpoint here, which looks kind of weird. I mean, this is, even though there are applications that work pretty similarly to how this one works, not many of them work this way nowadays. It's typical PHP kind of thing. Anyway, we have the full path of the file that we chose to click on, the file size, the type of the file, the char set, and all that kind of crap. There's also a download functionality. We can open up the file, which essentially redirects me to a non-existing endpoint, and then I can go back. The files themselves are just stored in a files directory and a root directory of the application, and it's pretty much the same freaking thing. We got an empty TMP folder. There's nothing interesting. I mean, you could just go back and forth circling around the whole freaking application and you just won't find anything interesting. There's a search functionality up here in the right upper corner, and just makes a bunch of Ajax requests, nothing too mind-blowing. There's also advanced search functionality, but it doesn't do anything. It just sends a post request back to the server and just does pretty much nothing. So if I just open up the source code of the page, I can see that essentially it's all gathered up in one place. The CSS, if I scroll down a little bit, I can see that like there's the HTML structure here. There's some script here, which is essentially HTML structure of some model or whatever. Then I go all the way down and I can pretty much discover what's supposed to be the front end JavaScript code of this application, and it essentially tells me nothing because I have it in Visual Studio because I copied the whole thing. I like my syntax highlighting and all that freaking stuff. I have it right over here. If I open up that folder, yep, I have it right over here. And it's not really interesting. It just tells you a few things, if I could put it that way, but nothing too interesting. It's just a mix of JavaScript and jQuery. There's a bunch of functions that are just coded in the whole thing, but they don't do anything. We have edit and save, and there's no such functionality on the web application. Latest release info, that doesn't exist in terms of functionality on the web applications, either. Save settings, create new password hash. This whole freaking application is just stripped off of a lot of the functionality. But this is essentially the search functionality, and as we can see, it just gets the path from the href attribute of the input field. That's actually not an input field, that's a anchor tag, anchor element somewhere in the HTML, and it's not like visible right away, because if I go to web application and try to inspect that, I really gotta just, where is it? Gotta search for that thing, and you cannot really find it right away, so just gotta look for it. But anyway, that's pretty much the AJAX request of the search functionality. And there's pretty much nothing interesting. There's a bunch of other things down here. None of them are too interesting. So I went through the code a bunch of times, didn't find anything. I was inspecting elements because it kind of behaves weirdly, if I could say, this application, because there's like a lot of, like if I come here to this thing, it's essentially some HTML element that's hidden, and when you try to make it visible, it doesn't show up. Then there's if I go here, there's another hidden input element, and I thought maybe this, because it has a name which essentially tells me it could be a parameter that could be exploitable, but it wasn't the case. Yeah, and it's just type hidden, and if you just make that visible, you can see a bunch of input fields here, and it's just a weird way to program an application and whatever. So next thing that we can actually do with that application, we see here in the right corner that there's a bunch of functionalities that each of these files has. We could preview the files, what they say, what their name is, and all that kind of stuff. We can use the direct link, which essentially is supposed to transfer us over to the file itself or where it's located, but it's not located in this folder as I previously discovered. So if I go to files, then slash, the name of the file is just gonna open it up for me and just show me its contents. It's nothing too freaking interesting. Next thing I have is like the copy functionality, and this thing here looks interesting. It looks like something that could be exploited. Essentially, the two parameter exists in pretty much everything. So if I go back to the home page of the application, the other thing that I did we could do with the files is just to download them, and I don't want to do that. But essentially, if I do it, it's just gonna, well, it's not gonna do anything here in the search bar. So you just essentially gotta intercept that request if you want to see what's going on behind the scenes. So what I initially did, of course, like with any web application, is just open up Burp Suite and see what's gonna happen if I try to intercept a bunch of requests. So the first first request that I actually intercepted was the search request, because it was a post request, and it was the one that was most interesting to me. So I have intercept on. I'm gonna just turn Foxy Proxy on and try to intercept that. If I just go to advanced search and try to search for something, just hit that button, it's gonna transfer me right over to burp, and it's just gonna ask me whether I want to forward the request or not. Before I do so, I'm just gonna send it over to repeater, then I'm gonna forward it. I'm gonna go back to the application, to Mozilla, and just turn Foxy Proxy back off. Go back to burp. See what I have here over in repeater. So this is essentially a normal post request, even though it's just some Ajax on the front end, and it right here it says Ajax true, indicating whether that's an Ajax request or not. This is the contents, essentially the search thing. I mean, like, this is essentially what we want to search for. It's what we enter in the search input field right over here. Next thing we have is the path, which essentially is supposed to be the path where we want to be looking for a file. It's just a dot. It doesn't do anything interesting. And the type of functionality, which in that case is search. So as I already have that in repeater, I can just try to do a few different things and play around with the content parameter, even with the path parameter, because this initially looked like a potential attack vector for me, but just for the sake of this video, I'm gonna use intruder and try to fuzz these parameters, and in order to try to figure out whether they're exploitable or not. So I'm gonna add a payload right over here. Then I have a bunch of word lists with potential payloads and things I could use in order to fuzz this parameter right over here. I'm gonna go with, I like the polyglot one, and some of these things I don't really like, because essentially most of the initial characters, like the semicolons and all that stuff, are not encoded. Maybe I can use something else, like the obfuscated one. It's no different than the first one. Maybe I would want to have yeah, I do have a character right over here, but that's not how I want it. I want to have the content, and then I want to have the payload right after the content. And maybe I could even go to, but it's a long one. I could fuzz it with FUF, but I just want to show you how to do it in burp, and these ones are just short word lists. This one only has 99 payloads in it, so I'm just gonna go with this one and see what happens when I try to fuzz and potentially exploit the search parameter, the content parameter of this request. And it just tells me pretty much nothing. It doesn't even show if there's something wrong. Like, if you try to do something bad on a web server, normally it would just give you some sort of feedback. Either it's going to be an error or something else, just a different kind of message. But this here is essentially the same HTML that we get when we go to the home page. There's just a bunch of payloads. It's like 99 payloads. All of these responses, they have the same length. So nothing too interesting. So after circling around back and forth for a little while through the application, I figured that this was not where the injection was supposed to be. I also tried to essentially exploit the 2 parameter, but it didn't do anything, as it would just treat this as a directory and it would just reflect it back to me here in the HTML. So this was essentially nothing, and it kind of looked like it was not exploitable. And even if I want to go back, I gotta click this. It's a weird ass application. So next thing I could probably try to exploit is the copy or the move functionality. So essentially I went straight to the move functionality. Essentially it's just copying a file from one directory to another in Linux, and there's actually a Linux command for this thing, and it's just mv, and if I just, yeah, this is mv, rename source to destination or move source to directory. So this could be what the whole application does in the under the hood when it comes to the move functionality, maybe the copy functionality as well. So I tried to copy a file to temp from here. If I do this, I don't know if it actually worked, but I'm gonna go back to temp. No, it didn't work. No, I somehow managed to move a file at first. This is the source path. Oh yeah. But if I do like that and then hit that, there we go. I managed to move a file from files to TMP, and if I go, I'm currently in the TMP directory. So the functionality works kind of well. I don't know. This is trying to access the file. If I go back to the copying functionality, what I'm gonna do is just send this to burp. Intercept that request. So let's just try once again. Send to repeater. Then I'm gonna send this, and it just returns. I think this is the HTML behind that page. Let me just turn that shit back off so it doesn't break the internet. So yeah, this is essentially the page, this page. And I gotta forward the request as well, so it quits hanging. If I go back to burp, more specifically to repeater, I can indeed see that this is the HTML behind this page. So what I have here is a to parameter and a from parameter. Since I have already tried to exploit this and it was not pretty interesting to me, I moved over straight to the from parameter. As I can see, when we're trying to make a request, it URL encodes special characters, and this I think has to be /. Yep. So I can try to add a bunch of different payloads here and see what happens. I can fuzz that, or I can just, let's try just something pretty basic like that and see what happens. Interesting, it just tells me that it was found. Why was it just found? That. Am I not logged in this whole freaking thing? So I'm just gonna intercept the whole request again, because for some reason it just broke down. Well, here in a URL I can see that I have like the destination folder and a source folder, and it's supposed to be TMP, and this here is freaking hell, god damn it, motherfucker. So yeah, this is to TMP. Let's just try to do that. Can I? Is it gonna work like that? Found not found. Interesting. Okay, let's just go back and try to copy a whole different file, because I really like how that application works. So this is the root directory where the files reside, and I'm just gonna specify that I want this one to be moved into the TMP directory. Then I'm gonna just turn Foxy proxy on, click move. It has to intercept the request, and it's this one. I'm gonna send it over to repeater. I'm just gonna forward everything, go back to repeater, back to the web application, turn Foxy proxy off, and start playing with this once and for all. And as I initially said, this is not exploitable as far as my knowledge goes, so I had to move over to the from parameter. I'm gonna keep the name of the file, and right after that I'm gonna start and try to just use some payloads in order to see how the whole application behaves. What I'm currently looking for is some sort of output that I'm trying to break the application, and I'm trying to do something that I'm not supposed to. So I'm just gonna use a semicolon in order to separate the command and try to execute who am I and see what's gonna happen. So we're just gonna return 200 OK. And what I'm looking for in the response of this request is some sort of interesting output. And as I can see here, it tells me malicious request denied. So essentially, this means that I'm trying to do something that's bad and that the server doesn't approve. So this looks like this could be a potential attack vector. But since it tells me malicious request denied, I'm gonna have to figure out a way how to get it to execute different things. So if I go, actually, I can try to encode this semicolon character and try to send the payload again and see what happens. So that's gonna be %3b, send that thing over again. and try to scroll the way back down to where I mean I can just essentially type malicious here and look for it, and it tells me once again that I tried to send a malicious request and it was denied. So this leads me to think that it's kind of filtering for ASCII characters, not ASCII characters, but letters essentially. So what I can do is just look for, let's say, separators that when they're URL encoded, they do not contain any sorts of alphabet characters. So one of those characters is called backticks in English. So if I try to encode this, it's going to come back as %16, %60. Well, there's also one other thing I could just... Oh shit. Where's Bursit? I could also try to... Let's try and execute the whole request with an ampersand, as it doesn't necessarily contain any letters. And since I cannot execute any normal commands because it blacklists all letters, I'm just going to try to execute a environmental variable, and that's going to be the host name. So I can kind of get real confirmation that this is actually exploitable, and that's the parameter that I've been looking for so far. So if I send that request and I scroll all the way down to where the output's supposed to be shown, I think it's somewhere around here. I mean, I can still look for malicious, whether the response contains that string or not. But alright, let's try to find out. But it finds no matches, so something must have happened. And what I wanna do now is try to find the place where the output is, and there we go. Message alert error while moving bash, and this is the host name of the machine that I'm essentially trying to exploit. So what I can see right here is, this tells me a lot. I mean, essentially it tells me that it's using the mv command under the hood in order to kind of move a file from one directory to another one, and it's essentially just executing system commands on the server. Only thing that I gotta figure out now is how to bypass all the filters that are essentially just enforced here. And one way to do that is to try and execute base64 encoded bash commands. And I'm gonna do this by putting the base64 encoded bash code between backticks, because the backticks essentially tell Linux, because this is a Linux machine, it tells Linux that there's going to be a subshell, so anything in between the backticks is going to be treated as bash code. So I'm going to get rid of all that up here, and I'm just going to specify that I want backticks right here, and the URL encoding of the backticks is essentially %60. So in between here, I'm just gonna try and execute some code. I'm just gonna specify bash. This essentially it replaces the pipe character. And this is actually subshell once again. And I'm gonna tell it to base64 decode, and I gotta specify that I want a space here, and that can be done by using that, which essentially translates into, I think, tab, if I'm not mistaken. Then I'm gonna specify -d, which essentially is gonna decode any base64 encoded text. I'm gonna specify pipe character without actually using it once again, and here I can actually put a Linux command that's base64 encoded. And normally I could just do that by using echo straight in the terminal, but I personally, for myself managed to, I just found some limitations, so I just wrote a simple Python script to do that for me. It also does some hex encoding, which is not going to be necessary for this, even though sometimes you could bypass filters by hex encoding commands. So I'm just going to go to where that file is, some JavaScript, open up that folder, some PHP here, and there it is. It's just obfuscator. And this is essentially the command that I use to kind of read the flag. But if I try to, let's see, I'm just gonna try to run env for now, see what happens. And if I just run Python obfuscator.py, it's just gonna give me the base64 encoding of this command here. So I'm gonna go back to burp, place that right over here, and try to send the request and see what happens. I can still look for malicious, and when I hit enter, nothing happens. So I gotta scroll all the way down and see if I manage to hit something or not. And there it is. It does actually execute bash commands, if I could put it that way, because as I can see right over here, I have all the environmental variables that are on this server. So from here on, I can just become a little bit more creative and try different commands. And if I think it was, I don't quite remember the syntax, I always forget that, but if I use the find command, I think it was, yep, so if I just do that, I'm gonna tell it that I'm looking for a file, the name of which would be something like this. Essentially, this is gonna try and find all the txt files on the server, and I gotta save, I don't have to copy this. Let's try and run this command and see what happens. So I copy that, paste it right over here. Because initially I tried to run the ls command in order to list the files in a directory, but for some reason it didn't work. I'm gonna try to look for malicious again. Nothing happens. That's why I'm gonna use the find command in order to, oh, there we go, it pretty much shows me all the txt files, I guess. That could be found on this server, but most of them just tells me permission denied, permission denied, permission denied. Alright, so if I go back to my script here and just change the command to, let's say, flag.txt, then maybe I can just, let's try to use cat. No, I'm just gonna first try to find it like this, and then I'm gonna try to use cat in order to try and read it. So if I clear the terminal, run the obfuscator again, it's gonna just give me the command both encoded in hex and base 64, and go back to burp. I replace this whole thing with the last command that I got. Send the request, look for malicious just to make sure that I didn't fuck up. Go all the way down to where that essentially gives me the same output. Permission denied. Permission denied. Permission denied. If I try to do this, I'm just gonna try to do different kinds of commands and see which one is gonna work. Essentially, you could just use cat/flag, but sometimes, let's say on a real engagement, you're not going to be looking for flags. You're essentially going to be looking for files that could potentially contain sensitive information, and not always you're going to know the names of those files. So just gotta get creative with the commands and just play around and essentially see what each of, oh yeah, there I go. Now this here, for some reason, told me that I tried to execute a malicious request. Let's go back to the command. Let's see what happens. I'm pretty sure it's because of the pipe character. And there's no environmental variable that I could actually use in order to replace this. Alright, I'm just gonna go back and try to find a flag like that. Python obfuscator, get the base 64 encoding of the file, go back to burp. Send the request. No malicious requests this time, but it's probably gonna give me a whole bunch of files that I don't wanna. Yeah. I have Apache too. So this is essentially how to, oh, there we go. This is actually where the flag is. At first I didn't see that, but it's trying to essentially append the output to the output of the command to the back of the full path of where the file is, because I have the file right over here and I have the command right behind it, so that's why it's trying to append it to the back of the file. So this is essentially where the file, the flag.txt is, and yeah, the find command definitely worked this time, even though there's like a whole bunch of other, these are actually directories, and from what I can tell, it's just essentially trying to go into each one of these in order to try and look for the file, but essentially it just goes to the root directory and it finds the flag. So as I initially had here in the cmd string, I could just do cat /flag.txt, save that, clear the terminal, obfuscate it, you know, it's base64 encoded, copy the output and paste it right over here. Then run the command, look for malicious just to make sure I didn't fuck up, and scroll all the way down to where the output is supposed to be, and I think I missed it because it's gotta be, there we go, error while moving, cannot stat, and there is the flag. So yeah, that's pretty much the bugs. That's how you find and exploit command injection. It's sometimes, and most of the time, it's a little bit harder to actually find a vulnerability itself, and it's like that's 50% of the whole engagement. Then you gotta exploit it. Sometimes it's harder, sometimes it's easier, depends on the application, depends on the developer who was responsible for building that application and how well they're aware of security and all that kind of crap, because to be honest, not all of them are. And you know, pen testers, adversaries and all that kind of people, they just always find a way to break an application. And if you really want to get creative and want to play with this, you could just potentially try and find other ways, other payloads that would also work. And that's that.